All right, guys, so here's what we're going to do in this video. We're going to try and write a function as an infinite power series. So basically, people have been telling me, Boris, series, they're very fun and easy. Can we turn every function into an infinite power series? And the answer to this is yes. And in this video, we're going to start with just a very simple case that I think is actually pretty limited in its scope. But first off, let's do this. Let's write f of x equals 1 over 1 minus x as a series. So how can we just do this totally random task, write this function as a series? And the answer lies in where have we seen this before? So where have we seen a 1 over 1 minus x, or perhaps a 1 over 1 minus r? Oh, it's the geometric series, right? It's geometric in the sense that if we have 1 plus x squared and so forth, that's the geometric, that x to the n, that geometric series adds up to 1 over 1 minus x, where your r is just the x, the part that's being raised to the power. So what that means is I pulled this rabbit out of a hat. We can write 1 over 1 minus x as equal to the infinite series from 0 to infinity of x to the n. Okay, now that's a way you could take this function and just write it as an infinite polynomial series. Cool. Now you might be like, Boris, I don't believe that those are the same. And I might say, well, let's graph them. So here's a graph of 1 over 1 minus x. And if you just graph the terms of the series, 1 plus x squared plus x to the third power plus x to the fourth power plus x to the fifth power, you're going to see, well, gee, they don't look exactly the same, but certainly the more terms I add, the closer they get. But one thing I do notice is that if we look between, -1 and 1, gosh, they look really similar. Very, very close, right? Interesting. And what's happening there, and again, if we just add more terms, we're going to see that it gets just better and better, right? And it gets more and more accurate. And of course, if I could add, if I could add an infinite amount of terms, then it would be an infinitely close estimate. But what I'm trying to show you is that the more terms you add, the better and better of an estimate you get. And if we look along this interval from -1 to 1, which certainly is the interval of convergence, by the way, we can see that that series is very similar to that graph. Okay, so let's go back to this and look at a couple other examples. But this, I think, is one key that we can start with. If we have 1 over 1 minus x or something similar to that, we could just write that as the geometric series x to the n. Okay, and we're going to use this as a building off point because our next step now is, well, what about something similar? So what if we can write 1 over 1 minus 3x as a series? Well, we're going to start with the geometric series. So we're going to start with 1 over 1 minus x. So we're going to start with that series right there. And then what's the only difference between 1 over 1 minus x and 1 over 1 minus 3x? Well, all we did is we replaced the x with a 3x. So we're going to replace x with 3x. So I'm going to replace the 3x there and there. Okay, so that means that 1 over 1 minus 3x is equal to the sum from 0 to infinity of 3x to the nth power. Okay, and there you go. That's how we can write that as a series. We're just taking this and we're substituting in all the x's with a 3x. Well, cool. Well, that's kind of similar, but what if it starts in this form, right? What if you have this series of something like y equals 1 over 1 plus x? Okay. So again, we're going to start with that situation of 1 over 1 minus x equals the sum of x to the nth power, the infinite geometric series. Well, if I want to, I can rewrite 1 over 1 plus x as 1 over 1 minus a negative x. Don't get confused by the plus. We can still turn that into a subtraction. So what I can do, again, is to replace that x with a negative x. So I can turn this into the sum of negative x to the n, which some of the cool kids, if you want, may have written as like -1 to the n times x then, but you could just leave it in that form too. So that's how you can write that as a series. Okay, and again, as long as you're on the interval of convergence, this series is equivalent to our normal algebraic function. Those are equal to each other. So it's not like an approximation. 1 over 1 plus x equals the infinite sum from 0 to infinity of negative x to the n on whatever that interval of convergence is. And that's why the idea of convergence is so useful, because it's saying where is it that we're allowed to write that function as a series. That's what we're finding here. Let's look at one more that we can write as a series. So let's write f equals 3x divided by 1 minus x to the fourth as a series. Okay, so again, our starting point on this is we're going to start with 1 over 1 minus x, which we know is the infinite series of 0 to infinity, of x to the n. So we're going to do something similar here. So we're going to say that if we have 3x over 1 minus x to the 4, I can just turn that into 3x times 1 over 1 minus x to the 4. Okay, and then something like this, I can again just replace the x with x to the 4. So I'm going to replace the x with x to the 4th power. So I'm going to take this x, replace that with x to the 4. So this is equal to 3x times, and then this series, okay, just replace that, so it's x to the 4 to the nth power. Okay, so this just turns out to be 3x times x to the 4n. Now, this 3x, that's a constant, right? The x isn't changing throughout the problem, so I can move that inside the series of n, which is changing in the series. So this becomes the series 0 to infinity of 3x times x to the 4n, which I could also rewrite as 3 times x to the 4n plus 1. So that's a way that I can write this function as an infinite series. And again, the key was to have this starting point right here for the geometric series, and just to build off that. Do the substitution first, and then after we're done, then we just kind of multiply that guy in after we've split it up. Okay, so if you have something that kind of looks like the 1 over 1 minus x, you can use these tricks to write it as a series. If you don't, but you still want to write it as a series, that will be the topic of the next video. But hopefully this helps and shows you what to do. You know, if you start with something like this that looks vaguely like a 1 over 1 minus x type term. Okay, well, thanks for watching, guys. Bring your questions to class, and I'll see you in the next crucially important video.